Assalamualaikum and hi everyone. In this video, we present our group project for ECG565 Highway Engineering, which is entitled Evaluation and Enhancement of Road Safety Features at UiTM Shah Alam. This project focuses on three critical pavement safety elements, which are skid resistant, surface texture depth, and surface drainage efficiency. So, these are our group members. The problem is that the pavement surface qualities have been weakened over time by environmental weathering and traffic volume at the UiTM Shah Alam parking lot region. Move on to the introduction. This laboratory project evaluates important pavement characteristics that play a critical role in roadway safety and long-term performance. The tests are designed to assess how surface texture and drainage behavior affect vehicle traction, water removal, and overall pavement durability. These are the three main tests that we conducted. First, the skid resistant test, which measures the level of friction on wet or worn pavement surfaces to reduce the risk of skidding and accidents. Second, the sand patch test, which determines the roughness of the road surface to ensure good tire grip and proper water flow. And the third, the surface drainage test, which evaluates how well water drains from the road surface to prevent hydroplaning and pavement damage. We conducted the test on two types of surface, which are rough surface and smooth surface. Before we begin the test, it's really important to highlight some safety precautions.
The first test we conducted is the skid resistant test. The objective of this test are to determine the friction characteristics of the road surface under different surface conditions and to evaluate the effectiveness of the pavement in reducing vehicle skidding, especially under wet and high speed conditions. As for the procedure, first, clean the test surface to remove dirt and loose particles. Second, level the tester by making sure the bubble is at the center in the bullseye. Third, loosen the locking knob so that the pendulum arm can swing freely. Next, calibrate the skid resistant tester by making sure the needle stops at 0. Then, adjust the level by making sure the slide rubber of the skid tester touching to the 3 points. Once the tester is ready, push the release button and record the data for dry condition. Take the reading 3 times to calculate the average reading. Repeat step 6 for the wet condition. Lastly, repeat the procedure at the smooth surface. The result data at location 1 with a rough surface, the skid resistance readings under dry condition gave an average of 101 and under wet condition is 77, while at location 2 with a smooth surface, the skid resistance readings under dry conditions gave an average of 106.33, while under wet conditions, the average was 61.33. So, these are the calculations of skid number for rough and smooth surfaces under dry and wet conditions. For the discussion, the skid resistance analysis for category C roadways reveals a clear performance gap between the two surface types. The rough surface successfully passed the safety threshold in both conditions, yielding a wet skid number of 62.45 and a dry value of 89.93. Its superior texture depth effectively maintains friction, making it suitable for standard roadway use. Conversely, the smooth surface shows a major safety risk when moisture is present.
While it passes in dry conditions with a skid number of 91.32, it fails in wet conditions with a skid number of only 42.32. This outcome highlights that the smooth surface requires texture improvements to prevent wet weather skidding.
Next is sand patch test. This test will be conducted to determine the average microtexture depth of the road surface and to determine the uniformity of the surface texture and its impact in tire-pavement interaction. Firstly, clean the selected surface, which is rough surface, by using a brush. Pour 50 ml of sand inside the measuring cylinder by using the funnel. Pour the sand to one point on the selected surface and disperse into circular motion by using surface rub. Record the length of the diameter of the sand and take the different sides of the diameter of this dispersants to get the average data. For smooth surface, clean the selected surface by using brush. Pour 50 ml of sand into the measuring cylinder by using funnel. Pour the sand to one point on the selected surface. Disperse into circular motion by using surface rubber. Record the length of the diameter of the sand and take 3 different sides of the diameter of dispersed sand to get the average data. The results show the different surface from different locations with a smooth and rough surface that has the same volume of sand and the average reading of dispersed sand. For the calculation, on the rough surface, it shows a mean texture depth is 2.2 mm. The value shows that it's greater than 0.5 mm, so it passed. Same to the smooth surface, giving a mean texture depth is 1.32 mm, which also passed the requirement. According to the classification tables, both surfaces fall under the open texture categories, with the rough surface showing a coarser texture than the smooth one. The sand patch test results show a clear difference in micro texture between two surfaces. For both surfaces are passes the requirement, which rough surface has higher texture depth also help drain water more effectively, which is important for keeping friction at higher speeds. However, the smooth surface has a texture depth is lower. The surface is more likely to lose skid resistance in wet conditions compared to the rough surface.
The last test for our evaluation and enhancement of road safety features is the road surface drainage test. The objective of this test are to assess the ability of the pavement surface to remove water effectively, and to detect location where the water accumulation may increase in the risk of hydroplaning and pavement damage. As the procedure rough surface of the surface drainage test are: first thing first, we put the outflow meter on the clean surface. Make sure the valve of the outflow meter is closed and pour the 200 ml of water into the outflow meter. Open the valve and stop the stopwatch to record the time. Stop the stopwatch after all of the water in the meter outflow comes out. Run the test for 3 times to get the average data. Repeat the same procedure for the smooth surface. Here, this is the result of the surface drainage test. Show a clear differences between the two pavement types. On the rough surface, 200 ml of water flowed in an average time of 4.56 seconds, giving a flow rate of about 43.86 mm per second. On the rough surface, 200 ml of water flowed in an average time of 4.56 seconds, giving a flow rate of about 43.86 mm per second. Meanwhile, on a smooth surface, the same volume took an average of 8.43 seconds, with a slower flow rate of about 23.72 ml per second. This means the rough surface drains water more effectively, while the smooth surface allows water to accumulate for longer, which can increase the risk of hydroplaning. This is the comparison result between rough and smooth surface. Rough surface show the higher value result of the flow rate rather than smooth surface. This is because the rough surface has higher texture depth compared with smooth surface, which means that it allows water to drain more quickly. The drainage performance analysis show a clear distinction between the two locations based on their flow rate values. The rough surface recorded a faster average drainage time, resulting in a higher rate of flow that efficiently clears water through its 2.2 mm texture depth. This indicates high drainage efficiency, which is vital for maintaining tire grip. Conversely, the smooth surface exhibits a slower average drainage time, leading to a lower flow rate due to its shallower 1.32 mm texture. While the smooth surface still allows for water movement, its lower drainage capacity makes it more prone to surface ponding and a higher risk of hydroplaning compared to the rough surface.